Section 9.4 has to do with the polar form of a linear equation. The polar form of a linear equation is P is equal to R times the cosine of theta minus phi, where P is the length from the normal, and this is I'm gonna draw you a picture here, from the normal, and theta is the angle from the positive x and the normal. So in other words, if I have on a coordinate plane, let's say I have this line right here. The normal is a line that's perpendicular to the line that you're talking about, and it extends to the origin. So this right here is the normal. So if you will, the length of this is P, and then this right here is going to be your phi. Okay, so that's going to be your phi on that. Okay, so now you're not going to have to be drawing these. You're just going to be converting back and forth between them. Okay, so let's say they want us to convert from a standard form of a line to a polar form of a line. So remember, the standard form of the line is ax plus by plus c. So here is some examples. The very first thing you're going to have to do is you're going to have to get it into standard form. So I need to subtract the 26. Okay, so there's my standard form of the line, but I'm converting it into polar form. And the way you do that is you divide these by plus or minus the square root of a squared plus b squared. So in this case, it's 5 squared plus 12 squared. Okay, so that's going to give me 25 plus 144, which is the square root of 169, which is 13. Now, how do I know whether it's plus or minus? It's going to be the opposite of whatever your c is. So in this situation, the c is minus. So that means this is going to be a positive 13 down here. So I have 5 over 13, and then I have 12 over 13, and I have 26 over 13, but that's a minus right there, which is a minus 2, because 26 divided by 13 is 2. Okay, so right here, I have figured out that my P equals 2. It doesn't matter whether it's plus or minus, because it's a distance. Okay, so that's part of what I need. So I've got that. Now I have to figure out what my phi is. So I'm going to have to make sure that my calculator is in radians. So go to your mode and change that if it's not there. And so what I can do is I can say the tangent of phi is equal to my sine of phi over my cosine of phi. And I get that from up here, okay? Actually, I'm going to come over here because that's actually after I've already divided it. So what I have here is the sine, and that should have a y there, is 12 over 13 divided by the 5 over 13, okay? So the tangent of phi is equal to that. Notice that they're both positive, so I'm talking about first quadrant. So I'm going to take my calculator and I'm going to go inverse tangent. So phi is going to equal inverse tangent of 12 divided by 5. Now remember, it's in radians, and so I get a 1.18. Now 1.18 is in your first quadrant, because remember, at 90 degrees it's going to be pi over 2, or 3.14 over 2. So this is still going to fall in that first quadrant. So now I've got everything I need to write my equation in polar form. So I have 2 is equal to r times the cosine of theta minus 1.18. So that is taking this equation right here and changing it into a polar form. All right, let's do another one. Again, this one's already in the right form, so I don't have to move anything over, but I'm going to divide it by, and it's going to have a negative value because it's the opposite value of the c, the square root of 12 squared plus 5 squared. So again, it's going to be 13. So that part's the same. So that's going to give me a negative 12/13 x plus 5/13 y minus 1 equals 0. So P equals 1. Then to find the theta, or find the phi, tangent of phi is going to equal 5/13. That's your sine, divided by the negative 12/13. Now, notice that the sine is positive, but the cosine is negative, so it's got to be in the second quadrant. So when I do this, so it's inverse tangent, remember it's got to be in radians, of negative 5/12, it's going to give me a negative 0.37. Okay, that's going to be in the fourth quadrant. I want it in the second quadrant, so I have to add pi to it, which is going to give me a 2.7. So that's going to be your phi value. So I have 1 is equal to r times the cosine of theta minus 2.7. Okay, so that's going to be your polar form of that equation. Let's do one more. Okay, I'm going to have to bring the 3 over on this one. Okay, so I have an x plus 2y minus 3 equals 0. I'm going to divide it by opposite sign of that, so it's going to be positive 1 squared plus 2 squared. So right here you've got the square root of 5. So I've got x over the square root of 5 plus 2y over the square root of 5 minus 3 over the square root of 5 equals 0. Well, one thing you can notice, they're both positive, so I know this is going to be in the first quadrant. To get the p, though, I have to rationalize the denominator, so p is going to equal 3 on the square root of 5 over 5. Okay, so I need that p, but now I've got to find the phi. So the tangent of phi is going to equal the 2 over the square root of 5 divided by the 1 over the square root of 5. So therefore the inverse tangent, which is what phi is equal to, is it's the inverse tangent of 2 over 1, which is going to give me a phi of 1.1, which would be in the first quadrant. So now I just have to write it. 3 on the square root of 5 over 5 is equal to r times cosine of theta minus 1.1. So it's the same technique all the way through. Now, sometimes they ask you to convert from the polar form to the rectangular form, which in many ways is a whole lot easier. You're going to use the sum and difference identity, if you remember that from the last chapter. And you're also going to remember that x is equal to r times the cosine of theta, y is equal to r times the sine of theta. So you're going to work this thing out. Okay, so I have 2 equals r times cosine of theta, cosine of 60, plus sine of theta, sine of 60. So you're back with your unit circle here. Now notice that they changed this to degrees. So if you have to use your calculator to find out what the cosine of 60 is, you'll have to convert from radians. Okay, so I get 2 is equal to, and I'm going to distribute the r times the cosine of theta times 1/2, because that's what the cosine at 60 is, plus r times the sine of theta times the square root of 3 over 2. All right, so notice right here, this is equal to x, this is equal to r. So I can rewrite it like this. 1/2 x plus the square root of 3 over 2 y, okay, because this is equal to y. Now, I would need to bring the 2 over, so I have 1/2 x plus the square root of 3 over 2y minus 2. But that is not in rectangular form because I can't have a fraction. So I'm going to multiply the whole thing by 2 to get rid of the fraction. So I have x plus the square root of 3y minus 4. And that would be the rectangular form of that polar form. Okay, let's do another one. Again, you're working it out using sum and difference. So 5 is equal to, r is on the outside right now, cosine of theta, cosine of 45, plus sine of theta, sine of 45. So, I'm going to go ahead and distribute the r. So r times the cosine of theta times the square root of 2 over 2 plus r times the sine of theta times the square root of 2 over 2. And so this is going to equal x, this is going to equal y. So I have 5 is equal to the square root of 2 over 2x plus the square root of 2 over 2y. Going to bring the 5 over, so square root of 2 over 2x plus the square root of 2 over 2y minus 5. And I'm going to multiply through to get rid of the 2. So I have 0 is equal to the square root of 2x plus the square root of 2y equals, or minus 10. Okay, so that is the rectangular form of that polar form. Okay, then we're going to do some graphing here, but I'm going to pause the video and come back to it. The last part of this section has to do with graphing in a polar form. So you're going to use your calculator to actually find values like we used to do when we graph like a line. So you have your theta, which you're going to choose values for, and these are going to graph a line. So you probably, do 3 or 4 of them. And you can use the store button on your calculator as long as you're in polar mode and radians, okay? So you'll have to go to the mode and make sure that your calculator's set up right. So let's do, that should be enough. And if I do the store button, what I'm going to get here, I'm going to get a -8, a -4.6, and a -4. And this should have been pi over 2. And this would be -4.6. Okay, so -8, now I'm going to let these be equal to 2. So -8, of course, throws it across, so we're talking right here. Okay, at pi over 6, which is right here, I'm talking about a -4.6. So 2, 4.6, maybe approximately right there. We're just estimating. At pi over 3, which is right here, I'm talking about a -4. So you're talking right here. And then at pi over 2, a -4.6, you're maybe talking about right here. So here's your straight line through here. Okay, so it graphs that line. Now the truth of the matter is you could convert it first, okay? So if you converted it and went through what we just learned how to do, you want to solve for your r, because r is going to be your unknown. So this is going to be 4 over the cosine of theta plus 2 pi over 3. Okay, and then you're going to use your sum and difference here. So 4 over the cosine of theta, cosine of 2 pi over 3, minus sine of theta, sine of 2 pi over 3. Okay, so I have values here. So, and I'm going to take this bottom and I'm going to multiply it times the other side. So I'm going to have an r times the cosine of theta, and then the value of that is going to be negative 1/2, if you look at your unit circle, minus the r times the sine of the theta, and it's the square root of 3 over 2, okay, equals 4. Now, this is going to be your x, this is going to be your y. So I have a negative 1/2 x minus the square root of 3 over 2y equals 4. Now, if you want to put it in y equals mx plus b form, when you solve for it, okay, algebraically, you would add this and then you would divide by the negative square root of 3 over 2. You're going to get this answer, negative 0.6x plus 4.61. Now, if you did that on a coordinate plane, 1, 2, 3, 4. Okay, there's your negative 4.6. Now, your negative 6/10 is the same thing as negative 3/5. So you would go down negative 3 and over to the right 5. 1, 2, 3, 4, 5. So basically you're talking over there. You're talking that line right there. Now, if you compare that to what we just did, you're going to see that those are the same lines, but one's on a polar coordinate plane and the other one's on a rectangular coordinate plane. All right, let's do another one. Okay, so we're going to graph it. First, we're going to graph it without converting it. So we're going to make a table. Okay, and let's do just a few values. Oops. Few values here. Now notice that I'm going to have to rearrange this one a little bit. Let's go ahead. We're going to get r is equal to 2 over the cosine of theta plus pi over 2. You can still use that in the store part of your calculator. So you have theta. So let's do 0, pi over 6, pi over 3, and maybe pi over 2. Okay, and then the r value, it's going to give you an undefined right here. It's going to give you a negative 4. It's going to give you a negative 2.3. And it's going to give you a negative 2. So when you go to graph that, let's see, at pi over 6, you're at negative 4. Okay, and we'll just let each one of them be that 1, 2, 3, 4. And then at pi over 3, you're at 2.3. Then at pi over 2, you're at 2. So you can see it is the horizontal line. Okay, now if you wanted to, you could graph it, you could alter it or convert it first and then change it. So if I converted this, hold on one second. If I converted it, I had 2 is equal to r times the cosine of theta plus pi over 2. And I could do out the right hand side, so I have r times the cosine of theta times the cosine at pi over 2 minus sine of theta sine of pi over 2. Okay, so and then I can distribute and come up with my values. So I have r times the cosine of theta. The cosine at pi over 2 is going to be 0. And then r times the sine of theta. The sine at pi over 2 is going to be 1. So right now I have 2 is equal to, this is going to be 0, so negative 1y. Or I could say y is equal to -2, which of course you know is the horizontal line through -2, which if you go back and look at what you've already graphed, that's what you got. Okay, so on the polar and on the rectangular, it looks very much the same. So, okay, do the best job you can on doing this homework. It's on page 578, 12 through 28 even.